students, welcome to this lecture. And as we were discussing about ellipse, so basically we have come to some results which I will write here and we will proceed further. So if we take x-axis and y-axis and this is origin, then there is a point S which is a, 0 called focus, and there is a line which is having equation x is equal to a by e, which is called directrix. There is a point A which is having coordinate a, 0. This is called a point which lies on the ellipse because as upon this length, which is suppose am, would be equal to as upon m would be equal to e, and which is less than 1, having some given value. So this is a point. There is another point similarly here which is a dash minus a, 0, and we also have a dash s by a dash m is equal to same e. So basically these 2 points are points on the major axis which are also called vertices of the ellipse, and they lie on the ellipse with focus a, 0 and directrix x is equal to a by e. But there are many other points, infinite points, which will lie on the ellipse. So if we take a point P, x, y, which lies on the ellipse, then what would we say that distance of this point from the focus and distance of this point from the directrix, that is PS upon Pn, will also be equal to E, same. Now we know the distance formula of 2 points that we already studied in class 10th. We also know distance of this point from this line, which is actually simply this distance, would be having this coordinate a by e minus this coordinate x, some mod of this. This is this distance Pn, and we also have this distance Ps from distance formula, which is x minus ae whole square plus y minus 0 whole square and under root of that. So we will put those values and then we will go for simplification. After simplifying, we will come across a final equation which is x square by a square plus y square by a square into 1 minus e square is equal to 1. So intermediate steps I am not writing here. If you are interested, you can do as a homework, and you can also check from our videos which will be coming in math section of coordinate geometry ellipse. Then we will do the whole equation. So right now you have understood that this is the equation of the ellipse, and what we do finally, this a square into 1 minus e square is a value which is always greater than 0 because e is less than 1. E is less than 1. So 1 minus e square is a positive value, a square is also a positive value. So this generally is written by another value or another variable, and the final equation we write x square by a square plus y square by b square is equal to 1. This is the equation of the ellipse where this b square is actually equal to a square into 1 minus e square. So this a square into 1 minus e square can be written in another form b square, and we can write this as equation of the ellipse, and this is the relation between b, a and e. So basically we have 2 values a and e, from there we get b. Then we will draw yes sir.
This a or 2a is also called length of major axis.
Yes.
And 2b is called length of minor
axis.
axis. Okay.
So basically if we draw the graph of this equation, we will get a curve which would be something like this, and you can see that this equation is symmetric in x as well as in y. You take plus x or minus x, you take plus y or minus y, it will give you same value because it is a square of y as well as a square of x. So this is a graph which is symmetric about x-axis, which is symmetric about y-axis. And this graph is cutting x-axis at a0 and minus a0. And if we talk about y-axis, so by putting x0 we get 0b and 0 minus b. So basically b dash is the minor axis and a dash is the major axis.
And this is called length of semi-minor axis and length of semi-major axis.
Yeah, half of the major axis will be semi-major axis and half of the minor axis will be semi-minor axis. So you can say that B is actually length of semi-minor axis and A is length of semi-major axis. Further, we can also here what you have to keep in mind after knowing everything in this order, because this graph is symmetrical graph, the graph of ellipse. So what happens after we draw a graph of ellipse like this and doing the derivation, we come across that this is focus, this is directrix, and this is a vertex, and this is also a vertex. Actually, ellipse has two foci and two directrices. This is a foci and this is a corresponding directrix. We could have taken a foci S dash minus a comma 0 here and the corresponding directrix as x is equal to minus a by e here. In that situation, a dash s dash by a dash this point is also e, where a dash is doing internal division and similarly a is doing external division. So there are actually two foci of an ellipse. Focus is having a plural called foci and these are the two directrices. But we have to keep always in mind that if we are taking a point, then the ratio of this point, the ratio of the distance of this point from this focus will have to take in from this directrix. If we are taking this focus, then this directrix. We can't take this distance from focus and this as distance from directrix. That would be wrong. So for this focus, this is the directrix. For this focus, this is the directrix. So from here, there is a very important conclusion which also gives us the definition of ellipse from some other angle. So sir, as we know in physics also there is some term called apogee and perigee, which you will of course study after this lecture in application of physics of ellipse. So that is quite related to what I am going to tell you right now. So you have, what happens if you take this ps dash and when you take this also, this is n, this is n dash. So ps is actually e times of pn because the ratio will be e, that is the definition of ellipse, and ps dash is equal to e times of pn dash. This distance by this distance is also same e. Now what we are doing, we are adding both of them. So ps plus ps dash is equal to e times pn plus pn dash. So what is pn plus pn dash? Geometrically it is very clear that this is n dash. So this is actually e n dash. So after seeing this, what we can do here, that finally ps plus ps dash is equal to e n dash, and actually n dash is the distance between the directrices, which is twice of a by e here, a by e here. So this is twice of a by e, and finally you get 2a. So actually there are two ways in which you can define an ellipse. One way from which we have started was that we need to know a point, we need to know a line. Point is called focus, line is called directrix. So if I take a point and a line, then ellipse is a locus of a point, path of a point, such that its distance from this point divided by distance from this line is always constant and it is equal to e. This is one definition. But there is another definition also, which says if we have 2 points, we are not taking a point and a line, we are taking 2 points, fixed points, which are called foci, s and s dash. Then locus of a point such that it moves such that the sum of the distances from the two focus is always a constant value. This is always a constant value. If you take ps plus ps dash, you go here p dash s and p dash s dash, the sum is actually always a constant value. ps plus ps dash is always a constant value, and actually this constant value, which is 2 A is greater than the distance between the two fixed points. This is greater than S dash. So you can take any constant value which is greater than the distance between these 2 points and move a point P following this rule. You will also get definition of an ellipse. So sir, I think we can conclude this result, and I think you can tell students what.
So students, what we have learned here is how to derive the equation of an ellipse, and there are two different methods by which you can derive the equation. One method was by the ratio which is equal to centricity of the ellipse, and the other is when the distance from two foci of a point remains constant and the constant is equal to 2a, obviously greater than S prime. So this is the two method by which you will arrive at the same equation, and the most standard form of the equation which Subbu sir just told us is x square upon a square plus y square upon b square is equal to 1. Obviously a and b are related. The equation were given in this discussion of the lecture itself. Also, I would like to remind you one more fact, that we can also calculate area of an ellipse. We are not going into the detail of how to calculate the area, but definitely we can remember the formula of the area of the ellipse. Since we already know what is A and what is B, I can simply write that the area of the ellipse capital A can be written as pi into A into B, where A is length of semi-major axis and B is the length of semi-minor axis. So now we are concluding this lecture. In the next lecture, we will discuss application of what we have learned here in physics, some important portion especially in gravitation. So thank you student for attending this lecture. Next lecture we will discuss the application part.